Imagine filming a speeding car and infinitely accelerating the footage until the car vanishes. What proof would we have of its existence? Time legitimizes its existence. Time is the only true measure, proving the existence of matter. Without time, we don't exist. Time is unity. From our perspective, time is linear, like a river flowing from past, present to future. Humans can only experience time in this forward-moving, constant manner. Time is the most used noun in English. It's versatile. We can kill, save, spend, or do time. Time heals physical and emotional wounds. We often wish for more of it, yet it remains both valuable and an enemy. Ultimately, time is what ends us all. Despite its ubiquity, defining time is challenging. Thinking practically, one might imagine a universal clock ticking consistently for everyone. 1 second passing for me is also a second passing for you and everyone else, an event beyond our control, like gravity or light. We perceive time as a steady flow from past, present to future, carrying us along helplessly. The most unsettling yet refreshing aspect of time is the unfolding future, shaped by our actions and unpredictability, bringing both great and terrible events. This part of our lives remains unwritten, or perhaps it's already written, and the division of time into past, present, and future is merely an illusion created by our minds. In classical mechanics, time is often seen as an absolute entity that progresses uniformly. This perspective is encapsulated by Newton's laws of motion, detailing how objects respond to applied forces and how they move and transform. However, this view of time has its constraints, particularly in explaining phenomena like time dilation, where objects moving at high speeds relative to each other experience differing rates of time passage. Unlike Newton's universal clock, relativity shows time as a personal experience. A second for me isn't the same as a second for you. Events don't have to unfold in the same order for two observers in the universe. One person might see a vegetable taken from the garden, cooked and served, while another might see the cooked vegetable taken from the plate, revitalized and put back in the garden. How events play out depends on the observer's reference point. This is due to the relationship between space, time, and motion. In everyday life, you are in your bedroom at 10:11 p.m., on the train at 7:15 a.m., and in the club at 1:40 p.m. You are always somewhere at a specific time, and always at a specific time somewhere. Relativity merges space and time into a single fourth-dimensional structure called space-time. We should think of time the same way we think of space, just as all of space exists outside our world, and any point within it can be described by coordinates. All of time exists too, with events described by their coordinates. Just as all spatial coordinates are valid, all temporal coordinates, events, are valid, meaning there should be no distinctions like past, present, or future. The universe and life within it aren't constantly changing and morphing, but are like a video where the present moment is just a frame. If we could access this video, it would reveal every event in our universe from beginning to end. This concept is known as the block universe, where change isn't real and the present moment isn't special. Considering this philosophically challenges the idea of free will. The Hafele-Keating experiment of 1971 proved relativity was real. Scientists J.C. Hafele and R.E. Keating took atomic clocks aboard a commercial airline and flew them around the world, once to the east and once to the west. Upon returning, they compared the airline clocks to those at the observatory in Washington and found the airline clocks had gained 0.15 microseconds. Modern experiments have repeatedly confirmed this aspect of relativity. The discrepancy between the clocks is due to time dilation. Time dilation relates to how time moves differently for a moving object. The faster an object moves, the slower time passes for it. For example, if you boarded a spaceship in 2024 and traveled at 99% of the speed of light for 5 years, it would be 2055 on Earth when you returned, but you would only be 5 years older. This means you effectively traveled 31 years into the future. When an object is stationary, all its motion is through time. As it moves, its motion is shared between time and space. The more it moves through time, the less it moves through space, and vice versa. This is important because, using the video example, one might think that all observers would agree on what happens in any given frame, any given moment. However, this changes due to the relationship between time and motion. For a moving observer, what happens in the frame will differ from what a stationary observer sees. Movement gives the person a different rate of time and therefore a different perception of the frame and its events. While relativity occurs on Earth constantly, the differences are usually imperceptible. However, if two observers are separated by a vast distance, say tens of billions of light years, their movement can alter their perception of the frame to include events in our past or future. If this is true, and our future or past can be part of another observer's perception, it must lead us to conclude that both already exist. The future is not unfolding, and the past is not inaccessible. The present moment, marked by the steady ticking of the clock, flows continuously and elusively towards a future that may exist only in our minds, an impression crafted by our brains. Gravity also plays a significant role with time. According to general relativity, time moves more slowly in strong gravitational fields, a phenomenon known as time dilation. This has been confirmed through numerous experiments and is now widely accepted in physics. For instance, time progresses more slowly on Earth's surface compared to higher altitudes due to the Earth's gravitational pull. Moreover, general relativity suggests that time can curve around objects with intense gravitational fields, such as black holes. This concept implies that time could potentially bend back on itself, theoretically allowing for time travel under specific conditions. While the notion of time travel remains speculative, general relativity's view of time as a fourth dimension opens the door to exploring these and other intriguing possibilities. Why does time exhibit a clear directionality? It moves from the past to the future, even though physical laws allow events to occur in reverse. This phenomenon, known as the arrow of time, remains one of the greatest mysteries of our universe. This directionality is thought to be linked to entropy, the measure of disorder in the universe, which always tends to increase. Entropy has been a fundamental law since the Big Bang, shaping the course of the universe since its explosive beginning 13.8 billion years ago. However, some experiments challenge the idea that entropy solely dictates the forward flow of time. The concept of a universe where all events exist simultaneously is both unsettling and comforting. Those we've lost aren't truly gone, just temporarily beyond our current reach. Yet, it also suggests that our influence over the future may be less than we believe. Despite our many uses of time, one challenge remains elusive: understanding it fully. Time is an enigma, a constant companion that shapes our existence in ways we are only beginning to understand. As we journey through life, it's crucial to remember that while we can't control time, we can make the most of every moment we have. If you found this exploration of time intriguing, don't forget to hit the like button, subscribe to our channel, and click the bell icon to stay updated with our latest videos. Your support helps us delve deeper into the mysteries of the universe and share our discoveries with you. Here's a thought to ponder. Time is what we want most, but what we use worst, said by William Penn. Let's strive to cherish our moments and use our time wisely. Thank you for watching, and until next time, keep questioning, keep exploring, and make every second count.